It says write the vector PQ as a column vector. So this time we haven't got a letter for the vector. We know that it starts at P and goes to Q, therefore the arrow is pointing in that direction. PQ, so if we write a vector that way, we write PQ and put an arrow across the top. And then find the magnitude of the vector PQ, i.e. find the length of the vector, and find the angle the vector PQ makes with the horizontal, which is going to be the angle beta there in the diagram. Now we have to be careful, because we're going this way and then down, so we're going to the left, then we have to say that the PQ is minus 5, and then down 3, which makes minus 3. To find the magnitude, we use Pythagoras' theorem. So Pythagoras' theorem will say, and this is a notation, don't forget, two straight lines with the vector in between, minus 5, now you need to put that into brackets squared, plus minus 3 squared. Now when you square a negative number, it becomes positive, so we get square root of 25 plus 9, which gives me the square root of 34, or 5.83 units. Now sometimes it's preferable to leave it like this. This is called an exact answer. This is called a decimal approximation to that number. In order to find the angle that the vector makes with the horizontal, then we need to find angle beta. So angle beta we'll find by the use of a bit of trigonometry. So this is opposite the angle, this is adjacent. So tan beta is opposite over adjacent. So tan beta will be 3 over 5, and therefore, because it's opposite, 3 over 5, tan beta will be tan to the minus 1 and 3 over 5, which is 31.96, which gives an answer of 32 degrees to 3 significant figure. So this has been a video to show you how to find write a vector as a column vector, find its magnitude, and find an angle horizontal that the vector makes with the horizontal. Hope you've understood, and I thank you very much for watching.